All right, good morning, boys and girls. So today we're going to focus on actually two things. The first one's going to be measuring capacity, which is also liquid volume. And the second one is going to be measuring mass. So you might see it on your papers as measuring mass and volume or measuring capacity and mass, but I just wanted to clarify that first. So the reason why we're doing them together is just because a lot of the pages go hand in hand together. And by that, I mean that there's a lot of similar questions, and I just want to be able to show you the difference between the different units of capacity that we're going to focus on and the different units of mass that we're going to focus on, so that you guys don't get confused when you see one or the other, or problems that are kind of mixed in together. So I'm going to start off with the definition of capacity. What is capacity? So capacity is the amount of liquid a container can hold. So we're talking about liquid. So that's why you can also call capacity liquid volume. So these are synonyms, or they mean the same. Capacity and liquid volume. And that's just the amount of liquid a container can hold. The next word that we're going to talk about is metric unit. So this is something that you have maybe heard before. I know you've all heard the term unit from when we did area and perimeter, and we said to always remember your unit. So whether that was inches or feet or centimeters. So unit is kind of just the label that shows us what that number means. So a lot of you for area would write down 10, and we would say 10 what? 10 fish, 10 markers, 10 what? So then you would say, no, Miss Horn, 10 inches. And I would say, okay, well, make sure you always write your units. So that's the same with measuring capacity and mass, is that there's a unit, which is a unit of measure in the metric system. And that unit that we're going to focus on right now, they're all going to be for capacity. So capacity and metric units aside, we're going to look at liter and milliliter. So these are metric units of capacity. So when you're measuring the capacity of something, which would be liquids. So liters. This is a word that you've probably all heard when talking about soda. I know that we did soda for solids, liquids, and gas. And when we did that, I brought in a 2 liter of Coca-Cola. So you all saw what a 2 liter is. So a 2 liter is actually 2 liters of soda in that bottle. And there's actually all sorts of other things that can be in 2 liters, like a 2 liter jug of water or milk or anything else. But that's just how we measure it. And that's a greater capacity. So that's something that's bigger. You'd maybe measure for the amount of liters that are in a pool or a big tank. So that's something that when you have a greater volume, a greater liquid volume. And the example that I used was a Gatorade or a Powerade bottle. And I actually have one here to show you today. Hopefully you can see it in this video. But I brought a Powerade bottle. And this isn't exactly a liter. It's actually just short of a liter. But I thought that it was the best example that I had for something that would be close to a liter of water or liquid. 1 liter. So the next word that we're going to look at is milliliter. So milliliter is labeled with a lowercase m and a capital L. I also forgot to mention that for liter, but liter is a capital L. And so for milliliter, it is a lesser capacity. So lesser. That's something that's going to be less than a liter. So when we're talking about a liter, it's about this much. When we're talking about milliliters, it's actually about 10 drops of water. So that's a very small amount of liquid. And I brought some for you today to show. So this is about 1 milliliter, but it's so small you probably can't even really see inside because it's only 10 drops of water. So hard for me to show you, but that should show you how small it is. When you look at the two next to each other, liter and milliliter, you can really see the difference in how much liquid this is and how much liquid this is. So that's going to be important when we're measuring the amount of liquid in different containers or in different things, because say you're looking at a whole pool. You're not gonna estimate the amount of water that's in a whole pool using milliliters, because that would just be insane and really hard to do because it's such a small amount of liquid. Whereas if you were to measure the amount of liquid in a pool using liters, that would be a lot more possible. It'd still be pretty tough, but it'd be a lot more possible than with milliliters. So then down here, I also wrote 1,000 milliliters is equal to 1 liter. So that should really put it into perspective. To get a whole liter would be about 1,000 milliliters. So that's crazy. You would need 1,000 of these containers with this amount of liquid to fill up that other container of Powerade. So that's pretty crazy. And if you pause this video to take notes, which I forgot to mention in the beginning, I kind of, just to make it a little more clear, did green for liter and purple for milliliter. So I thought that would kind of help separate it even though it's on the same sheet. So to kind of review, when we're talking about liter or milliliter, we're talking about capacity and liquid volume. So how much liquid is there and which one are we going to use to measure it? We'll get into that more specifically. But for right now, I want to move a little into mass. So mass, what is mass? Mass is the amount of matter or material in an object. So matter, where have you heard the word matter before? Back to my soda example, you should have probably all heard what the word matter was when we did solids, liquids, and gas, because we talked about how it all has matter and it all takes up some sort of space, and it's how much space it takes up in the object. So when we're talking about mass, we have two different metric units, but these metric units are referring to mass. Our metric units before, on the previous page, were referring to capacity. So when we're talking about mass, we have two units that we would use for right now. One of those is kilogram, or labeled kg, both lowercase, and that's when you're talking about a greater mass. So my example is a baseball bat or a dictionary. And a dictionary, obviously it doesn't have to be a dictionary, but basically we were just trying to give a good example for something that would be a little heavier, more dense, and have more mass to it. So this book is actually called Teach Like a Champion. It's one of my college books. So it's a pretty thick book, and if you hear it thud, that kind of gives you a good estimate for what 1 kilogram would be and the amount of matter that would be in 1 kilogram. So it doesn't have to be a dictionary, but that should just put it a little into perspective for you, especially when we compare it to a gram, which is labeled G, and that's for lesser mass. And the example I have is a paperclip. Hopefully you can see that fine. So a paperclip, when you hear it drop, it's not so much of a big thud. It has less matter because it's just 1 gram, or about 1 gram. So when you're talking about different objects, just like we were talking about with liquid volume, when you're talking about the mass that it has, if it's a lot lighter of an object with less material, it's gonna have less mass. So it's not exactly the same as weight, which we'll get into later, but it's gonna have less mass. And if it's something with not a lot of mass, like maybe a little mouse or a piece of paper, if you tried to do it, weigh it in kilograms, that's gonna be pretty tough because it's so different. And that's what you use for something with a greater mass. Whereas something with a lesser mass, you would use a paperclip. So at the bottom here, I have 1,000 grams equals 1 kilogram. So I did the same thing with color coding it, so hopefully that helps you separate the two. But it would take 1,000 grams to get to a kilogram. Or it would take you 1,000 paper clips to get to be the amount of a dictionary or a baseball bat or something else of equal mass. So that's pretty crazy. And so mass can be a little tricky So I wanted to go into it a little deeper and give you this example. Make sure it's centered up here. So this is just something that'll help you. You don't have to take notes on this. But when you hear gram, imagine holding a paper clip. When you hear kilogram, imagine holding a dictionary. So I used the same colors and I separated them here just as I did the same on the previous page. And I just wanted to help put this into perspective for you. So when we look at a few examples that we have, the first one that I see is a bike. And it says 8 grams or 8 kilograms. Because I know that a lowercase g stands for gram. And I know that a lowercase kg stands for kilogram. So now I'm gonna think, a bike. If I'm holding 8 grams, that would probably be equal to about 8 paper clips, or 8 kilograms, about 8 dictionaries. A bicycle, I'm thinking that 8 grams wouldn't be enough because 8 paper clips doesn't seem like enough mass to equal out to a bike. So I'm gonna look at 8 kilograms, and when I think of 8 dictionaries or 8 sturdy books or 8 baseball bats, I'm thinking that makes a lot more sense. And as an estimate, I think that 8 kilograms would be a lot better of an equivalent number to a bike than 8 grams. So you can see that's kind of how I break it down. And I'm gonna do another one. So a baseball, 150 grams or 5 kilograms. So 150 paper clips or 5 dictionaries is kind of the way that I would try and visualize it. So 150 paper clips to equal a baseball. Okay, that's a lot of paper clips. So that one it could be, but let's check our second answer. Our second answer is 5 kilograms. So 5 dictionaries. So I'm just thinking that 5 kilograms would just be too much and that it would be a lot more than a baseball. So I'm going to guess 150 grams. For the next one, I see a backpack. And our two options are 3 grams or 3 kilograms. So for 3 grams, 3 paper clips, that's not seeming like enough for a backpack. And then 3 kilograms, so 3 dictionaries, that makes a lot more sense. So I think 3 kilograms. Another strategy you can do is that when you think that one might be a potential answer, leave it. Then when you decide on one, go back and check 3 grams. No, that's definitely not enough. And then you can cross it out. So we've talked about doing that. So I'll do it with my other few. We've talked about doing that with different multiple choice questions that we have. And it's just really great for when you go back and check your work so that you can say, okay, I really know that that one did not make sense. So that's a great strategy to use. So then our last one here is house key. So for a house key, 2 grams, about 2 paper clips, or 2 kilograms, about 2 dictionaries, 2 big books. So that seems like a lot for a house key. So I'm thinking that 2 kilograms does not make sense. That 2 grams would be a better guess. So then down here, I have this little thinking bubble, and it says, think about it. Apple, 25 grams or 3 kilograms. So that one can be kind of tricky because we're looking at 2 totally different numbers, 25 and 3. And grams and kilograms, there's no number there. It's not like 8 and 8 where I can simply compare the 2, or 3 and 3 where I can simply compare the 2. So this one's a little tricky because it's not anything super drastic like up here with the 150 and the 5. So because they're so close, that might be a little trickier. So what I'm gonna have you think about to have in the back of your head would be this statement. Would an apple weigh about the same as 25 paper clips, or 25 grams, I have the G in parentheses, or 3 dictionaries, or kilograms, I have that in tiny little parentheses too. So would an apple weigh about the same as 25 paper clips or 3 dictionaries. So I'm thinking that 25 paper clips sounds like it could make sense, or 3 dictionaries. So that just sounds like it would be too much because it's only 1 apple. So I'm going to cross off the 3 kilograms and circle the 25 grams. So I hope that kind of helps with breaking down how you would compare the two. So I know we did that a little more with mass and not so much with capacity. So we're gonna look at capacity a little more right now. I know this says my homework, but I just didn't really love the whole group portion of the my math. So I'm gonna focus right here on the my homework part. This is what you guys would normally do for homework, but we have you guys doing the 2 pages of independent practice, which you guys should have in a PDF. So instead of the whole group portion that's usually before that, I'm gonna focus on the my homework part right now, just because I thought it had better examples. So it says circle the better unit to measure each capacity. So since we're talking about capacity, that's when we talked about liters and milliliters. Those were the 2 different kinds of capacity, 2 different units of measure for capacity. So I see a nail polish container and I see the option of milliliter and liter. So when we're talking about the amount of volume in it, I'm thinking of comparing it to my little container with the droplets of milliliter, 1 milliliter, or this Powerade bottle that's 1 liter. So I'm thinking that the Powerade bottle just sounds way too large to compare to this smaller nail polish container. So I think milliliter makes sense. I don't think milliliter or liter makes sense. Therefore, milliliter would be the best option. The next one that I see looks like a big bin or a big barrel. And the 2 options are milliliter and liter. So when I think of milliliter, I'm thinking of a few droplets of water. And when I see liter, I'm thinking of my big Powerade bottle. So milliliter, I'm going to cross off because I think that just does not make sense. I think that liter makes sense because we're talking about a much larger volume to fill. So that's why I think that liter makes the most amount of sense. For number 3, I see a gallon of milk. I'm assuming it's a gallon of milk just because I know that that's the shape of a gallon of milk. But it looks like it's a large container of milk, bigger than around what the Powerade bottle would be. So I immediately right off the bat know that milliliter would just be too small and not enough. Whereas liter would make sense because it's the better unit to measure what looks like a gallon of milk. And for the last one, I see a sippy cup. And so this one's a little tricky because it's bigger than the container that I have for milliliter, but it's smaller than the container I have for liter. But when I'm thinking about giving an amount that a number that would go before this unit, I think it would be harder to do liter because it would be less than 1, because I know it is less than 1 liter. Whereas milliliter makes sense because it's more than a milliliter but less than a liter. So I'm gonna say milliliter for number 4. So you can see how I kind of broke down each of those questions. And basically you have to just decide, is it more than a liter where you would use liters? Or is it less than a liter where you should use milliliters? So that's the question that I want you to have in the back of your head. Is this more than a liter or is this less than a liter? All right. So then the pages that you guys are going to do look something like this. It should say practice it. And you have all of these questions on the front that are similar to what we have been doing. And then all these questions on the back. And anything that wants you to use containers that you do not have in your house, which is why I did not do the whole group portion of my math because it wanted me to use actual bottles and measure them. But I just know that that's not realistic and not everyone has those things. So that's why we're doing these ones here. So if for some reason between this and the performance coach, you guys find a question that wants you to actually use something that you don't have in your house, just go ahead and skip over it, okay? And so next we're gonna go back to mass a little. As you can see, I'm kind of bouncing back and forth between the two. And, but right now we're gonna focus on mass. So this is what the page that you guys are going to be doing for mass looks like, along with this page. And then again, I'm going to do my homework just because it's a better example than what the whole group example has for us. So for mass whole group, let me just take a second to get my papers organized. So when we think back to our notes about mass, we talked about comparing a paperclip and a dictionary. So the paperclip here is a kilogram. I mean a gram. The paperclip is a gram, not a kilogram. Gram. And our dictionary, or big book or baseball bat, is the kilogram. And have that in the back of your head for when we work through these practice ones together. So the first question, it says, circle the better unit to measure each mass. When we talk about mass, we know that we're talking about grams and kilograms. So a bowling ball. A bowling ball, we know from experience, is very heavy, dense, pretty big. So when I see gram and I think of this little paper clip, I just think that'd be pretty crazy to compare. When I see kilogram, I think of the dictionary. So I think that that would be much better for giving a unit or for measuring a bowling ball. I think kilogram would be our best bet. So I'm gonna cross out gram. And when you're working through all of these with mass, if it's something that would be 1 kilogram or more, we would do kilogram. If it's something that we think is less than a kilogram, that's when we would do a gram. So I know that I keep comparing it to the paperclip in the dictionary, but that's just because I'm not there with you guys and I want to make sure you have a great visual. So that's why I'm comparing so much the paperclip in the dictionary. So number 2 is zebra. So our two options are gram and kilogram. So gram, I think of the paperclip, which right off the bat sounds so crazy because a zebra is a big animal, and a gram, I think of this tiny little paper clip. So then I see kilogram, and I think that makes a lot more sense because I'm gonna choose kilogram because I think that a zebra is greater than 1 kilogram. So we would use kilograms to measure. Cell phone, number 3, cell phone. So our options are gram, 1 gram, so that would be about a paper clip, but probably a little more, but not quite a kilogram because a cell phone is still not that much matter, whereas a dictionary, that's a pretty sturdy, heavier object. So I think that gram makes more sense for a cell phone. I don't think a cell phone is quite up to a kilogram yet. Number 4, laptop computer. So a laptop's bigger than a cell phone. And I think it's just enough to the point where I would actually choose kilogram instead of gram because a kilogram makes more sense because I think it's at least about the same or more than a dictionary, which would be about a kilogram. Number 5, a pair of socks. So for a pair of socks, I see gram and kilogram. I think that gram could possibly make sense, but let me check to see if kilogram makes sense. So kilogram, I don't think that a pair of socks would equal 1 kilogram. So I'm gonna cross that off because gram would be a better unit of measure for measuring the mass of gram. Number 6, a marble. So for a marble, and remember that's just a small little glass ball, I see gram and kilogram. So gram, I think that makes sense. Kilogram, I think that that's way too much. So I'm going to circle gram. And then down here, it's just 2 more problems. So 7, I see graham crackers, which is funny because we're here talking about grams, different gram, but for the graham crackers, there are 4 grams or 4 kilograms. So now I have to think, 4 paper clips or 4 dictionaries. And remember, the paper clip is kind of just an estimate, and so is the dictionary. It's not exact, but when you think about it, 4 dictionaries for 4 kilograms, that just sounds like way too much. I don't think it can reach 4 kilograms, so I'm going to select 4 grams. And for number 8, I see a house key, 2 grams or 2 kilograms. So we did something similar to this. 2 grams, that could make sense. 2 kilograms, I think that's way too much. So I'm gonna do 2 grams. All right, so I hope that that really helped you guys break down the difference between gram and kilogram, liter and milliliter. And remember, for this one here for mass, you guys aren't gonna see this page, either of the homework pages for mass or capacity, but you will be doing the page that looks like this. The page that looks like this. And then there will be performance coach pages that practice them both. So again, if you need to, go ahead and go back in the notes. Use those performance coach numbers to practice. Remember, you don't have to do all of them. And if any of the questions anywhere for this, and actually for science, we'll make note of that as well. But for any of that, I know that it's better if you have the objects right there in front of you to really help you estimate things, but we know that that's not possible. We're not at school. So any question that's maybe asking you to use something, a material that you don't have, just go ahead and skip over this. Remember that this is just for independent practice. And once you work through both my math sections and both performance coach sections, you'll take your quiz and they both relate back into this video. So remember to check your answers with the answer key and let me know if you guys are struggling with any of this. So have a great day. If you need to use this video for both Wednesday and Thursday, go right ahead. If you want to take all the notes that I took in the beginning, go right ahead. Anything that you need to do to be successful. So have a great day, boys and girls, and I hope you all do fantastic.